these truths to be self-evident.
That all men are created equal.
As a member of Congress, I get to have a lot of really interesting people in the office, experts on what they're talking about.
This is the podcast
For insights into the issues.
China, bioterrorism, Medicare for all, in-depth discussions.
Breaking it down into simple terms. We hold
these truths.
We hold these truths.
with Dan Crenshaw.
The Eagle has landed.
Welcome back to Hold These Truths. And today we're going to talk about a topic that, well, frankly, as you know, I talk about a lot, which is climate change, what to do about it, our energy mix, all of it. And, fundamental to the debate about the solutions is an accurate assessment of what the problem is. And, for a while that debate was simply between alarmists and deniers. And I think in the last 10 years, there's been a much more sensible conversation that has emerged, which is, this is sort of a lukewarming conversation. There's clearly no alarmism that is necessary. It doesn't mean there's nothing happening. And maybe we can come to a logical conclusion based on the evidence about what to then do about it. And we have with us today a very qualified person to talk on that topic exactly, former Undersecretary for Science at the Department of Energy under President Obama, actually, Steve Koonin. Steve, thanks for being on.
Great to be chatting with you, Dan.
So, your book Unsettled gets a lot of controversy, of course, especially from the alarmists. It's really gotten out there. I mean, you were on Joe Rogan talking about it not too long ago, right? I guess my first question, actually, let me read a bit about your bio, and then so people know really who you are, and we'll go from there. So you're an American theoretical physicist, former director for the Center for Urban Science and Progress at New York University, also professor of Department of Civil and Urban Engineering at NYU's Tannen School of Engineering. From 2004 to 2009, employed by BP as the oil and gas company's chief scientist. So I'm sure they've labeled you as just a spokesperson for the oil industry.
Shill is the noun. Shill for the oil companies.
Yeah, and then in 2009, 2011, Undersecretary for Science at the Department of Energy in the Obama administration. So you got the qualifications, you got the scientific background very clearly to at least be able to parse through the data and come to some logical interpretations. I mean, what was it that actually drove you to even dive into this particular issue?
Yeah, so I was asked by the American Physical Society in 2014, which is a society that represents about 50,000 physicists worldwide. I was asked to look into their statement about climate change, which needed a refresh. It was about 7 years old at the time. And I said, well, heck, we're physicists. We're not going to take anybody's word for it. We're going to look at it hard ourselves. And I convened a meeting in Brooklyn. I'd been at New York University then for a year or so. And, three consensus scientists and three what I would call skeptics, or people would call skeptics. And we sat and talked for a day. And I came to realize that the science was not as settled as I had been led to believe. And then over the subsequent years, I watched the gap grow between what the media and many politicians were saying versus what the science actually said. I wrote a couple of op-eds in the papers, and then finally got so annoyed and felt I needed a more fulsome voice. And so I spent about 3 years writing this book, Unsettled.
Mm-hmm. And maybe we should start with the premise of what you think is happening, about what you think we can say for sure, and then we can tackle some of the misconceptions. And as somebody who deals with this a lot, for instance, I know what the IPCC report, the UN climate report, says is actually quite a bit different than what the headlines say. And so, curious what your take is on that report and what we know for sure.
So, first of all, let's distinguish between climate and weather. Weather is what happens every day. Climate is a 30-year average of weather, and all the statistical properties, the average, the variance, and so on, over several decades at least. Mm-hmm. And so people often confuse what happens this week or this year with a change in climate. Yeah. When you take that long-term view, which you do through weather records and proxies of various sorts going back centuries, what you discover, first of all, is that the climate varies a lot on its own. And that's due to many factors. Internal variability, it's just got a lot of sloshing back and forth. There are external forces like volcanoes going off that cool the planet through the aerosols that they produce. The sun varies a bit. The Earth's orbit changes, the way sunlight falls on the Earth. All of those drive changes in climate on many timescales. So the climate's changing, absolutely, and it always has. At the same time, we have seen over the last century or so that humans are exerting an influence on the climate in two ways, at least two ways. One is through the greenhouse gases, mostly carbon dioxide, but also methane, that are accumulating in the atmosphere due to the burning of fossil fuels. And also humans put up their own aerosols, of course, because we burn things like dirty coal, which exert a slightly cooling influence on the climate. And the net effect of humans is a net warming effect. But that warming is actually a very small tickling perturbation on the overall climate system at the level of 1% or so. And so it's not implausible that that's causing the Earth to warm, but identifying that warming or attributing it firmly to human causes, and then figuring out how much it's going to warm in the future, what the effect of that warming is going to be on weather patterns, severe weather in particular that we care about, and then what the overall effect of that will be on ecosystems and human society. All of that is up for grabs right now and depends a lot on very difficult modeling calculations.
Yeah, and we'll get to that. I mean, there's such a complex set of variables in this particular issue, unbelievably complex. And usually when you take an issue and the scientific community is trying to tackle it, trying to understand it, and there's an unbelievable amount of variables, the approach is usually very cautious. I mean, the scientific method demands that kind of caution and that kind of questioning. And it's just not what happened with this particular issue. And what makes this particular issue so politically charged? Because everything you said is, you're obviously not denying it. You're obviously not a denier. You're not an alarmist. It seems like a very rational approach, just being very honest about what we know and what we don't know, and what assumptions we're making and how many variables they are. That is often the approach taken with most issues in civilized Western society, but not with this one. Why do you think this is so politically charged?
I think there are several reasons for it. One is that climate does strike at the heart of human existence. Mm-hmm. Ever since the Bible was written, you've got the notion, and probably even before, you've got the notion that human behavior can affect the natural world. The media find climate stories unbelievably enticing, whether it's the latest heat wave or flood or hurricane and so on. It really gets people's attention. And then I think there are a number of scientists who really believe that they're saving the world. And that's a pretty heady feeling. And of course, the politics, I'm of course talking with somebody who's a politician, but you may know H.L. Mencken in the early 20th century said the purpose of politics is to keep the electorate alarmed by a series of mostly imaginary hobgoblins so that they can be clamoring to be led to safety. So it's a wonderful motivator.
Saying the quiet part out loud.
Yeah.
A lot of, yeah. And in politics, like I see that all the time, the purposeful exaggeration of an issue because you need people to pay attention, right? And they believe that the ends justify the means. So you're lying to people, but for good ends. Because in the end, it's better for them, right? It's for their own good. And
we can decide what's good and what's bad. I mean, that's a separate way.
Yeah.
Whose axe is being gored here, for example. If it were not about energy, which is in the end about energy, you would say, okay, let it go on. But it is about energy, and energy is the lifeblood of society. And if you go messing with that in ill thought out or unjustified ways, you can do a lot of damage. And I think we're seeing some of that already in the last couple of years.
Yeah, absolutely. And I definitely want to get to the solutions proposed. And this is where it gets very political, because policy, by at least one definition, certainly my definition of it, is fundamentally a judgment about trade-offs. And that's what a good policymaker is supposed to do. And then you judge those trade-offs within some set of principles. That's what makes you conservative or liberal or, whatever. But in the end, it's just trade-offs. And so, this is where like Republicans have started making the case in a very serious way. It's like, I don't want to debate the climate science with you, not too much anyway. Let's just talk about how crazy your solutions are.
Yeah.
And how the cost benefit just doesn't make sense. I want to add something else though to the why behind this, because you quote a lot of you have a bunch of good quotes there that really are these people saying the quiet part out loud. They almost know it's not true. So here's one. In order to convince the public that the work was important, climate researcher Steven Schneider says, so we have to offer up scary scenarios, make simplified, dramatic statements, and make little mention of any doubts we might have, end quote. Paul Watson, co-founder of Greenpeace, quote, it doesn't matter what is true, it only matters what people believe is true, end quote. Timothy Worth, president of the UN Foundation. The UN has its own foundation? Okay, anyway,
So.
we've got to ride. So we've got to ride this global warming issue. Even if the theory of global warming is wrong, we will be doing the right thing in terms of economic and environmental policy. That's definitely the quiet part out loud. That's exactly what we're saying. It's like this ends justify the means kind of talk.
And that's unbelievably arrogant, okay? Because all of those folks lived. Steve Schneider at least is passed on, sadly. I guess some of the other folks as well. That's unbelievably arrogant, because they live and we live in a very comfortable Western lifestyle.
Mm-hmm.
But there are 4 or 5 billion people who are clamoring for more energy. And to tell them that they can't have affordable, reliable energy smacks of carbon colonialism.
Okay, so now I want to go through a lot of the assumptions that get made about models and temperature, and you really in painstaking detail debunk all of these. Where's the best place to start with people usually?
I'd like to start with the observational data. I mean, as a scientist, my touchstone is the data. It's pretty hard to measure the climate system. The Earth is pretty big. We don't have good surface observations everywhere. The ocean is 2/3 of the land, and that's hard, or 2/3 of the globe, and that's hard to cover. But climate really happens under the ocean, because the ocean is the memory of the climate system. It absorbs 90% of the incremental heat. Its time scales are decades to centuries, as opposed to the atmosphere time scales, which are a couple days. And so observing the ocean is key. And it's very difficult to do that. Only within the last 15 years or so do we start to have good coverage of not only the surface of the ocean, but down to 1 kilometer or 2.
Okay, and what do we see when we look at that?
We see that the ocean over the last 50 years has been slowly warming. You say, oh my God, it's getting hotter. Well, the answer is the warming is in hundredths of a degree, but there's a lot of energy in that. Mm-hmm. And the oceans, at least for the last 50 or 60 years, have been absorbing about 0.25% of the energy flow through the climate system. That's a pretty small number, so it's kind of hard to model it. We'll get to that in a minute. But because of the long time scales in the climate system, we don't know, is that 0.25% anomalous? Is it due to human influences? Or is it something that's been happening since the world has been coming out of the little ice age? And we know certainly the world has been warming since the 1600s by quite a bit, but not as rapidly as we've seen it warming recently. So that's kind of where you start. All right. There are puzzles in the observational record. For example, the globe was warming about as rapidly from 1910 to 1940 as it did from 1980 to 2000. Human influences were less than 1/5 of what they are today, back in the early part of the 20th century. So
Mhm.
how did that happen? And it actually cooled from 1940 to 1970, even as human influences grew. How did that happen? What it says is that there's a lot of natural variability in the system. And unless you understand it, or as we modelers like to say, unless you have it under control, it's kind of hard to attribute any recent changes to human influences.
One thing that comes to mind when you say that is, wouldn't these models, if they're accurate for 50 years from now, couldn't you use the model with the data from 50 years ago and see if the model gives you the world that we have now?
Exactly. That's called, in the business, it's called hindcasting. And it's got some problems with it. Most importantly, you need to start the model somehow. Let's say we start from 1900 and wanted to describe the 20th century. You got to start it in 1900. That means you got to know the ocean currents, the ocean temperatures, the state of the atmosphere, although that doesn't matter very much because it washes out after a couple of weeks. But there are things you don't know. And moreover, these long-term modes, the cycles in the climate system, perfectly natural, that last for many decades. You got to get those started at the right time and with the right magnitude and so on. So no single model can reproduce the observational record. And what they do instead is they build 50 or 60 different models from institutions all around the world. They average them, and well, they sort of describe what's happening, but if you look in detail, they don't get it right.
There's huge variability between the models themselves
Right.
based on what the assumptions and inputs are into
Yeah.
them. So it's a constant. It's in the end, it's a subjective debate.
Yeah, and their average surface temperatures, for example, differ by more than the surface temperature change you're trying to describe. And so some models run 2 degrees hot, others a degree cold, and so on. And
Even
they
the
kind of-
current,
Yes,
even the current measurements.
Yeah.
Wow.
yeah,
So
yeah,
it's not
yeah.
even their projected
Yeah,
variables.
right.
But
So what they do for that is they say, well, we're interested in changes, so we'll shift all the models back to the current temperature and then look at how they change going forward. It's about the best they can do. I can't fault them for it, but we should not place too much confidence in these models.
so again, going back to the temperature,
Yeah.
you said it has warmed. It's warmed more rapidly, somewhat recently. Where is that warming happening? And in another thing that you kind of debunk or at least question is, New York Times publishes this heat map of the U.S. about where there's these hot spots, which you point out are most likely associated with urban growth, which does create more heat, concrete, and all that. So, but again, how much of this is true and how much of it is questionable?
Yeah. So in general, I think the globe is warming. I think, many signatures that that's happening. The warming is greater toward the poles than at the equator, and it's greater at the North Pole than the South Pole. The warming is greater over the land than it is over the ocean. And the warming is greater at night in the cold parts of the world than it is in the warm parts during the day. And so there's a general compression of the temperature range, and the average is going up. And we can kind of understand all of those different aspects.
So somebody who's really scared of climate change will say, that's exactly right. The North Pole is warming really, really fast. All this ice is going to melt. We're all going to flood. How much do you go into that in your research? Is it likely that in reality, the sea levels would rise dramatically because of that?
Well, nobody knows. So let's talk about sea level a little bit. Just finished a piece which I'm submitting on sea level around Manhattan, which is where I live part of the time. And, sea level on average has gone up, 1.5, 2 inches a year. I'm sorry, every 30 years over the last century. But it hasn't gone up smoothly. It's gone up and down and up and down. And we kind of understand, but can't model that. Mostly the ups and downs are driven by how much ice is lost from the glaciers in the mountains and how much ice is lost from Greenland and Antarctic. That's where ice or water is on the land, and when it is lost, it finds its way into the ocean and causes the ocean to rise. Melting of ice, the sea ice in the Arctic, will not raise the sea level. Because that's like ice cubes in a glass melting, and they don't raise the level of the water when they melt. But then another factor, which will become increasingly important as the oceans warm, is the expansion of the oceans due to the fact that the water is getting warmer. Warm water is slightly less dense, and that is expected to become a dominant contribution. Now, NOAA, the National Ocean and Atmospheres Agency or Administration, put out a report in February that said that sea level around New York and most of the East Coast would go up by a foot in the next 30 years by 2050. That's more than double the current rate and is 3 times the average rate we've seen over the last century.
So then how do they justify that?
Well, they say the oceans are going to warm. We got these models and the ice is going to melt, and they put it all together and they say it's going to go up by a foot. But first of all, that's a remarkable number. As I said, it's very discordant with what we've seen in the past. But also what they've said is remarkable in that they said it's locked in, it's guaranteed. Independent of emissions, of models, and so on, you're going to see a foot of ice. And so we'll know, I think, within a decade, whether it's going to be doing that or not. My own guess is it won't, because it is so discordant with what we've seen in the past, which is already highly variable. But, who might dispute NOAA, right?
You make another interesting point about the sort of equilibrium of heat around on the Earth in general. So given that, and we'll, I guess radiative equilibrium is what it's called, this sort of this principle that the heat must balance the absorbed solar energy very precisely. How does that work? Unpack that for us.
So the Earth is warmed by the sun. The sunlight is absorbed by the Earth. About 70% of the sunlight hitting the Earth is absorbed. The rest, 30%, is reflected back into space. When that sunlight is absorbed, the 70%, it heats the ground, heats the water, heats the atmosphere. And you got to get rid of that energy somehow, otherwise the planet would burn up. It would keep absorbing energy and get much too hot. And so the way it gets rid of that energy is by sending infrared radiation, heat energy, back into space. And the amount of heat energy sent back into space has got to very precisely balance the amount of sunlight absorbed. Again, because if it didn't, the planet would warm up really quickly. And so there's got to be that balance. Now, the absorption of sunlight is complicated because of the clouds. The clouds are there and they help reflect the sunlight, so it changes the reflectivity, that 30% number. But the atmosphere also influences the heat radiation. And in particular, the atmosphere is very effective at capturing the heat as it comes off the ground and then releasing it again, both back into space and back to the ground. And that absorption and re-radiation of the heat by the atmosphere is the greenhouse effect. And so it makes the ground or the surface warmer than it would have been by about 30-something degrees centigrade. And it also guarantees that the energy in the end gets sent back into space.
So does that mean just based on these principles that the Earth can never warm too much? Is that the point you're making, or are you just describing the
Well,
system?
if you made the atmosphere completely absorbing so that it trapped all the infrared radiation and then sent it back into space, the temperature would go up to 310 or something like that. I can't remember the exact number. I work it in my class when I teach it. But the atmosphere is partially transparent.
Mhm.
As I said, it captures about 80 something percent, 82% of the heat coming off the ground and then re-radiates it to space. And that's what makes the surface temperature 288 degrees Kelvin. If it were 83%, it would raise the temperature a little bit. If it were 84%, and so on. And what the greenhouse gases do is to increase that absorptivity a little bit. And we're talking about very small changes. So, as I said, the 30% of the sunlight gets reflected. If that number were 31% rather than 30%, it would counteract all of the warming caused by human emitted greenhouse gases.
Yeah, and it's sort of one of the theories that comes out about geoengineering the skies and creating this like reflective. I don't know how realistic that any of that really is. I mean, what do you think?
Well, it could be done. The question, of course, is should it be done, or will it be done?
Yeah, they
but I
make
think-
movies about this stuff where we like freeze the earth because
Yeah. I don't think it would get out of control like that, but it doesn't exactly counteract the greenhouse gases. And as always, there will be winners and losers. The warming that we're seeing currently, if it's due to greenhouse gases, will benefit some parts of the globe. If you're in Canada in the Midwest, hey, that's pretty good.
Right.
On the other hand, if you're near the equator or in the deserts, maybe it's not so good. So as you said a few minutes ago, everything involves trade-offs.
Well, one thing I want to mention on the models before we're too far from that point was the different kind of predictive models that there are. And if you could go through like the most likely, the most unlikely, but how they actually promote the most unlikely scenario the most in this kind of like worst case scenario.
Right. So predicting the climate, let's say 50 or 100 years from now, depends on a couple of things. It depends on the model itself, the internal processes that you've built in to the model and how they're described. But it also depends upon your assumptions about future greenhouse gas emissions and aerosol emissions. And for a given model, you can make different assumptions. And the IPCC has fixed on a set of 4 different scenarios or assumptions about future emissions.
Mm-hmm.
And they're labeled by numbers. We don't have to go into the details of what the number means, but there's a scenario that's 8.5, which is a very coal heavy, population heavy, high emissions scenario.
Mm-hmm.
And there's another one, 2.4, which is more or less what today is and emissions wise. And then there are a couple in between. And the reports consistently use the worst case, the 8.5, as kind of the benchmark. They talk about them most often. From a scientific point of view, you can understand that because that scenario hits the climate system the hardest and makes it easiest to see the response. But from the point of view of describing to people what might happen, even the IPCC says this is a very unlikely scenario, and it's one of the more moderate futures that are much more likely. And so, those show some warming. We'll probably see another 1.5 degrees of warming by the end of the century under the most moderate scenarios, but by no means the 5 degrees or so that people used to say is what's going to happen.
Yeah. And look, in the end, people are worried about actual weather events if they're worried about climate change. And so to make the case stronger, the alarmists will talk about hurricanes, wildfires, precipitation. So let's go into what's true and what's not true, especially with hurricanes, right? These big, severe events. We got a lot of them in Houston, although we haven't had any in a couple of years.
Yeah. So this was one of the surprises for me when I started digging into it in 2014. I had occasion, or 2015, I had occasion to look at the record of hurricanes. And in the front of the government report, at the time, the most recent government report, it says hurricanes are getting worse. And they show you a graph of some property of hurricanes over the last 40 years, and sure enough, it's going up. But then you go in the back of the report and you find there are no long-term trends. in any hurricane property at that time. Okay. And I said, what the hell is going on? In the back of the book, you tell me nothing's happening, where at the front, that it's the part anybody reads, if anybody reads anything at all, you tell me things are getting worse. And so that got me really annoyed. If you read the most recent UN report, the 6th assessment report of the science, which was released last August, it says there is low confidence in most reported long-term, namely multi-decade to centennial trends in tropical cyclone, that's hurricane frequency or intensity. There is one small thing that at the time they thought there was some data that showed that the strongest storms were becoming more intense. But in fact, subsequently, there was a paper that said that isn't necessarily true. It's just historical fluctuations. So I think at least for the hurricanes, mostly there's nothing happening, and it's unsettled whether there's anything happening at all.
Mm-hmm. That's an important point. So would you say that, because you referenced the IPCC report, is the UN climate report, you referenced it a lot, and I've noted to my listeners quite a bit that it's for the most part pretty decent science. It's just that how it's interpreted by politicians and journalists that make it seem alarmist, but it's really not that. Would you say it's pretty good? Assessment?
I would have emphasized a couple of things where they leave out some things sometimes, but by and large, it's pretty good. And the reason I kept referring to it in the book is because it is the gold standard.
Mm-hmm.
But I like to quote the line from The Princess Bride, you keep saying the science. I don't think the science says what you think it says, because nobody ever reads the actual report.
Yeah.
People get their information by this long game of telephone that starts from the reports, goes through the summaries of the reports, which are actually not very good at all in terms of fidelity. And then you get to the media and people who want to spin the story. And so most people don't get their science from the scientific reports.
Yeah. What about precipitation? So you tend to agree with the idea that the precipitation levels haven't really changed, but there might be more concentrated events.
Yeah, right. So in some parts of the US, we're seeing more intense precipitation in the Northeast in particular. The fraction of the US that's been under intense precipitation has gone up from about 12% at the beginning of the 20th century to maybe about 15% now. There's an EPA graph that shows that. Is that natural? Is that due to human influences? Pretty hard to understand. There's limited evidence and low confidence in what's called hydrological drought, which is the flows of streams and rivers. In meteorological drought, there's low confidence in the human contribution to observe trends at the regional scale, with a few exceptions. So, no great changes. What's interesting about all of these extreme events, you can do a nice physics-style calculation. Another op-ed I'm working on. If you say, how often does a 100-year event happen? And you have to say, well, how big is an event? Let's say 100 miles on a 100-mile side. It's about the size of a storm or a flood. There are 6,000 patches like that over the Earth's land. And so if you ask, how often does a 100-year event happen? You might expect it's going to happen 60 times a year somewhere on the globe, or about once a week. And so there's plenty of events for the media with global coverage and round-the-clock news cycle to talk about.
Yeah, and of course they do, and we think we dealt with this, like in Houston, a massive rain events, probably one of the biggest in history, 50 inches in like a couple days with Hurricane Harvey. It was really insane. I mean, this weather system just stayed there, just never left. And there's an honest debate, like, is that going to happen more? Because that's obviously more damaging than, you got to triple the times of rain, but if it happens over the course of a few weeks, it doesn't really matter as much.
Right. Yeah, we get fooled. I like to tell the story, if I can just spend a minute to tell the story, which is great. We have this record of the height of the Nile River over 1,000 years compiled by the Egyptians. And I won't go into the details. It's a nice cultural story. But if you look at the annual minimum that the Nile hit every year, starting in about 640 AD, it goes down. It takes about a century and it goes down. And you can just imagine some medieval Egyptian climate panel screaming, new normal, and recommending some prayers and sacrifices. And if you just wait a while, another 50 or 100 years, it goes back up higher than what it started with. And of course, all of that is natural variability. It proceeds to go up and down over the next 1,000 years with kind of 50, 100-year timescales. And so we can get fooled by this natural variability. The drought in the Southwest that we're experiencing now is the worst drought in 1,000 years or 1,200 years, whatever. But it happened before. And that says natural variability has got to be a major contributor to why it's happening.
Yeah, and we're dealing with drought in Houston right now. We're anticipating a higher than normal hurricane season. I think they said that last year also, though. We didn't really see it, but it's it's just so hard to pin this stuff down. And another question I have is, or that I pose because I sort of know the answer, which is, what can you really do about it? I mean, let's say that these effects are real and they're largely contributable to human actions. How much can you really even change that over the next 50 years and at what cost? And this is what really gets into the policy side of it. And is there at any point where we're going to make all of our weather look like San Diego?
Yeah. Right. San Diego. I know San Diego, so I'm actually going out there next week again.
Yeah. Smart man. Good place.
Yeah, it's a wonderful place. Look, the first thing is carbon dioxide is in the atmosphere for a very long time. We put it up there, it stays there for a century. All right. So anything you do now is not likely to have much effect for many decades. The second is that, what's up there is the concentration, not the emissions. The emissions add to the concentration every year. And so if you reduce emissions, what you've done is reduce the rate at which the concentration is growing, but haven't reduced the concentration itself.
Yeah.
The third is that fossil fuels, most of the CO2 comes from fossil fuels. Fossil fuels provide 80% of the world's energy right now. And energy is so important. It's also very slow to change for very good reasons. So if, people say we've got to reduce emissions immediately, we've got to go net zero and so on. That's such a naive statement. It ignores the dominance of fossil fuels, the recalcitrance of energy systems, and in fact, the fact that most of the world is hungry for energy and wind and solar just ain't going to do it. All right.
And even in our most likely scenarios, what do we anticipate the actual economic costs to humans being? Because people say, oh, you just care about the economy. What about your life? I'm like, well, the economy is kind of a measurement of my life.
Yeah.
So
exactly.
I think it's hard to distinguish between the two things. So what does the UN report say about that?
This is one of the other surprises that's buried in the UN report. The last report from 2014 had a graph that said for a warming of as much as 4 or 5 degrees centigrade, remember Paris is talking about 2 degrees, that we'd see an impact of about 4 or 5% on the GDP in 2100. So 4% on the GDP for a very large warming is 2 years of growth. If the GDP is growing at 2% a year, it's 2 years of growth. Yeah. And that means the growth of the economy will be delayed by 2 years, 80 years from now.
Yeah.
This is in the noise. Okay. And you can say, well, that's the US. What about the world? Well, the graphs for the world as a whole show the same thing. And you might say, well, what about tipping points? The Atlantic slows down or the Arctic outgasses. The economists have made estimates of that also. It's another percent.
Huh.
And then you go look at the most recent UN report, which came out in February on the economic impact. And it basically says the same thing. We have very low confidence that it's going to be any worse than what we said in the last report. All right. So it's in the noise. So
Mhm.
all of this stuff about net zero finds very little scientific justification, at least according to the science. Now, you
Yeah.
can dispute the IPCC, but again, who am I to do that?
Yeah, I thought that was the consensus. So, if we're going to say that, this is my point as well. I make that point about the 4.5% all the time. And I'm like, that's not nothing. I mean, it is a cost, but it's pretty damn close to nothing in terms of costs and things that hurt
Right.
the world. I think there's a lot bigger things to worry
And
about.
the report says I could read you the wording if I pull that up. It says that there are many other factors, technology, demographics, regulation, etc., that are much more important than climate in
Well,
the well-being of the world.
you mentioned these tipping points. What about them? I mean, what are some of the scenarios that people talk about, and how likely are those? I mean, it's
Yeah.
one thing I hear is like the permafrost is going to melt, which releases way more CO2 all of a sudden, and then we're really
Yeah.
screwed. We burn up like a match.
Right. Yeah. It would actually release methane, not CO2, which is even more potent greenhouse gas.
Okay, so that's the point.
It's not implausible that would happen, but we don't see any estimate of it. And again, the economists try to factor in how much of an impact would this have on the economy, for example. And
Mhm.
as I said, it's a couple percent. Another one is, one of the ice sheets on the Antarctic comes loose and a whole bunch of ice rapidly goes into the ocean. Well, okay, but there's rapid on a human timescale and there's rapid on a geologic timescale. So I wouldn't get too worried about that. Another is that the current, like the Gulf Stream that carries heat from the equator to the poles in the Atlantic, would slow down, and it would make the pole colder, or the northern regions colder. Europe would get colder, and so on. And there were some measurements of 5 years worth of data a couple of years ago that said, well, maybe it's slowing a little bit. But as I said, there's so much variability. I don't think we know about that. So I don't lose sleep worrying about that at all. One of the things that most people forget is that humans are remarkably adaptable and resilient. And that is maybe one of the dominant characteristics of our species. The pandemic that we've just been through and hopefully is now behind us, a great example of how we marshal our knowledge and thought and regulation and logistics and so on to cope. And yes, a million people, or however many million people around the world died. That's terrible. Each individual case is awful. But as a species, we're doing just fine.
It's actually a good analogy to the pandemic because while it's a great example of a lot of human ingenuity, it's also a great example of how this alarmism can cause people to do some really crazy shit. Excuse my French.
Yeah, no,
but,
no.
I mean,
right.
because I don't know where you are on this particular subject, but I'm of the belief, and I think the data certainly bears this out, at least in hindsight. I'll forgive people for making different assumptions early on in the pandemic, but in hindsight, pretty dang clear to me that lockdowns don't have this measurable effect on spread.
Yeah.
Everybody's gotten COVID. If you haven't gotten COVID by now, I don't know how that's possible.
Yeah, I don't know that I've gotten in. I might have, but it's another good example in a slightly different dimension, because you had the public health folks at the beginning saying lockdown, 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 and maybe they were justified in saying that at the beginning, but even if they were, they don't determine the trade-offs, the values, because you had the public health debate on one side, but then you had the psychological and economic effects of the lockdowns on the other side, and it was the job of the political system. And I think the individual governors in the end did do a pretty good job at that, of trying to balance those things at the state level. And the climate's just the same thing. If there were no other considerations, you'd say, sure, let's reduce emissions. But there are so many other considerations that speak on the other side that you've got to discuss and weigh, and as you say, strike that balance based on priorities and values.
Yeah, I mean, honestly, the more I think about it, the more similarities there are to the two issues, because it's about, there's that emotional aspect of it, and people's lives are on the line. The climate, as you stated before, weather is in your face all the time. It does cost lives, it costs livelihoods, and it's a very emotional topic for people. And fear drives people in some pretty crazy directions. And then there's people who have some kind of agenda, and want to perpetuate that fear and exaggerate things. Hell, God, we see it in politics all the time. And the right is just as guilty as the left. Maybe not at scale. I'm biased, of course, because I'm on the right. But I see it, and I'm like, you're just scaring people for no reason. But the left really does it. God, they do it, and it has serious consequences. In America, I think we're better on COVID than most countries. But I mean, the fact that China still doing crazy things over there and just shutting down entire cities. And, we wonder where our supply chain crises are coming from. It's because of these ludicrous presumptions about how to stop the spread of COVID.
Right. And I think I'll get to stray into politics a little bit. I think Xi has kind of painted himself into a corner with this net zero COVID or no COVID. And he's got a lot riding on that. And he's doing crazy stuff. The thing I worry about in the US and maybe for the globe as a whole is that the climate discussion, the overhyping of the threat will cause us to do crazy things, batshit crazy things with the energy system. And the energy 100%. System really matters, okay? As you know, in Texas, all right?
Yeah, I mean, look, and this is the second part of the conversation, which is the solution. So we've established some form of truth, I think, on what the science tells us. It's not quite what the alarmists say. It's not quite what the deniers say. It is. There's a happy medium about what we know, what we don't know. Now, but the real question is, of course, what are our actions in response to that? And this is where the left and the right just dramatically veer. Yeah. Because, and I have a feeling we tend to agree on this. Given the problem as stated, it doesn't make sense to spend an absurd amount of money, resources, and frankly, lives trying to fix it. The cost benefit just does not work. And what I can't understand either from my colleagues up here is I think they think electricity just comes out of the wall. I think that might be a presumption that they're operating off of, because I can't understand just the antipathy towards oil and gas, when in reality, I make a good argument. If you really want to reduce emissions, you export more natural gas and you displace coal around the world. That's an infallible argument. You cannot argue against me on this. It will happen if you try to make it happen. But they don't. I mean, it's very ideological. What's your general take on that?
I think in the end, reality will catch up with us.
Like in high gas prices. I just don't know how much more people are willing to bear. But anyway, of course there are political ramifications of all of that. But again, if you want to take CO2 as a global problem, and when you say we have to reduce emissions promptly, I think about that scene with the Lone Ranger of the joke, where Lone Ranger is talking to Tonto and they're surrounded by Indians, and Lone Ranger says, "Tonto, we're in real trouble." And Tonto says, "What do you mean, we, white man?" Right? So, when you say we got to reduce emissions, I think what you get from India and China and all of the developing countries is, what do you mean, we? They're starving for energy, and they need it now. And they're going to do what they need to do in order to get it. The other important point is if we go to zero emissions tomorrow in the United States, I think the IPCC projects that we might reduce global temperatures by like 0.3 degrees Fahrenheit. Am I getting that right?
I think that's pretty high. We're only 13% of emissions right now. And of course, it's the cumulative emissions that matter, and the rest of the world's growing fast. So it hardly matters what the US or even the US and Europe do. Okay.
Right.
The best thing we can do, if we really want to get there, is to work to develop and demonstrate emissions-light technologies that are no more expensive than the alternatives, and that the rest of the world can then adopt.
So what are your favorites on that front?
So I'm a nuclear physicist by training, so I'm not afraid of the atom. And I think small reactors have a lot going for it. And the government, to its credit, is trying to do that. I helped get that started when I was in the Department of Energy. I think alternatives to petroleum-derived fuels for heavy vehicles is a pretty good idea. And, we can make hydrocarbon fuels out of many different forms of carbon, including bio. There are other things like ammonia that you could use to run heavy vehicles. And then I think the electrification of light-duty vehicles, passenger cars and light trucks, is something that's going to happen. And it's only a question of just how rapidly it will happen, because quite apart from the CO2 advantages, there are other advantages to electric vehicles, but you can't do it too quickly. And I think we're going to overload the grid. We're going to have issue with copper and some of the other metals that go into electric vehicles if we do it too rapidly. But I think it will happen.
You better figure out the supply chains before you make these drastic changes.
Not only the supply change, but the supply itself. I mean, if electrification of vehicles proceeds at the pace people are expecting, we're going to see, I can't remember, some vast increase in the demand for copper over the next decade. And we're just not going to be able to do that.
It frustrates me about those estimates, like, these things are going to solve all our problems, is they're deliberately not measuring, I think, the emissions that occur from the massively more excavation of materials, whether that material is copper or cobalt or whatever it is. They don't take that into account. And I think I forget the exact, electric vehicle definitely takes a lot more material excavation,
stuff,
a lot more than a normal car.
And it's true for all of the new energy technologies,
all of it.
Per kilowatt capacity, a wind turbine is like an order of magnitude more than a gas turbine. So
it's like 10 times more. I do have those numbers.
An order of magnitude, an order of magnitude.
And by
so
land
we're
use
digging
too,
a lot of more
more
stuff. Yeah, we're going to dig a lot more stuff out of the ground. And nobody, I'd like to say, there was a guy who once told me, the only humans who don't pollute are dead ones. And even that's not obvious. Right? So, pick your pollution poison, right? Do you want it to be mine-tails, or do you want it to be CO2 or whatever?
On the nuclear question, real quick, how feasible is it for us to develop a good supply of uranium? I had Peter Zion on this podcast just a little bit ago, real interesting kind of geostrategist, geopolitical thinker. And he actually wasn't very bullish on nuclear and at least for the United States. And when I asked him why, he said that one of the main reasons was just lack of uranium deposits. What do you think about that? And also, because what I mentioned to him was reprocessing. I mean, why can't we reprocess all the nuclear waste we have now? What are your thoughts on this?
Okay, so let me do the uranium supply first. One fundamental thing you have to understand is that the major cost of producing electricity from a nuclear plant is in the capital cost. The operating costs are quite small. And included in those operating costs are fuel, uranium, separated and enriched uranium. And so you could see a big increase in the cost of the uranium and still not see much increase in the cost of electricity. And uranium, like all resources, has a cost curve. If the price goes up, new deposits become commercially viable. In the extreme limit, we can separate uranium out of seawater. Perfectly possible. And if the price were high enough, we'd have it. Also, there are plenty of uranium resources in friendly countries around the world. Australia is one of the big ones, even though they're a nuclear-free country. And so I wouldn't worry about the fuel, not worried about the fuel.
Well, okay. And then the other, why does the environmentalist left really not like nuclear? I think they're coming around slightly, but at the recent COP26 in Glasgow, nuclear barely had an appearance there. It just seems so obvious that if you care about two things, reducing emissions, but also energy reliability, that you would really push hard on nuclear. But we get very lukewarm receptions to that, and here in the Congress, Democrats are kind of favorable to it, but they won't take any steps to make it more affordable, deregulate it, make the permitting easier, nothing.
There's a guy named Spencer Wirt, who's an historian of science, who wrote a book called Nuclear Fear, maybe 40 or 50 years ago. And basically, he traces it back to the Frankenstein myth of not messing with the powerful forces of nature and being afraid of things that you can't see or touch.
It's as simple as that.
yeah,
I think they're
so.
also caught up in like the special interests of the solar and wind lobby.
Yeah, well, that's a relatively recent phenomenon, but yeah. So
Yeah.
let me turn to reprocessing for a minute.
Oh yeah.
Yeah, it makes sense to reprocess only if you're short on fuel.
Mhm.
And as I described, we will not be short on fuel. And reprocessing brings with it proliferation concerns.
Yeah, that was
which-
Peter's point.
Yeah, and I would say do not reprocess. We don't need to. And there's some risk associated with it anyway.
All right, plutonium hanging around,
Yeah,
a couple pounds of it. That's
not good.
it's dangerous.
Not good.
Now, I think we've hit most of the points that I don't usually hit in my podcast. And as I promised you, and we're going on an hour here, and as I promised you earlier on, I really wanted to pick your brain about some theoretical physics stuff. So changing
Okay.
subjects for a minute,
Yeah.
because I find this stuff really fascinating. When I was laid up about a year, just over a year ago, I went blind again. So that was great. Had a retina detached. And so I was face down, no sight for, some time. And I used that time to really go down some rabbit holes that I usually don't, because I'm always reading and doing policy and politics. And I was like, I don't want to think about that crap when I'm dealing with this. So I'm going to listen to say, what's his author's name? But he does like it's a great courses, lecture, a series of lectures on multiverse theory, really making the case for it, as opposed to say string theory. So this is the explanation for all things, like getting Newtonian physics in line with Einstein's relativity theories. So and quantum mechanics. So that's the background. That's about as expert as I can talk about it. I'm curious what your thoughts are.
Yeah. So as the world, the scientists started in already the 19th century to understand the different forces of nature. We started with electricity and magnetism, and Maxwell in the late 19th century demonstrated that they were really the same thing. Famous Maxwell's equations. We then had Einstein with special relativity, extending Newtonian physics, namely when things started to go near the speed of light, how do things change, and demonstrated that they were really the same thing. We had the quantum mechanical revolution, which then got integrated or fused or aligned with relativity in field theory in the 50s and 60s. And we gradually have developed a pretty coherent theory now called the Standard Model, which integrates the electromagnetic forces, the weak force, which causes beta decay, the strong force that holds nuclei together, into one more or less comprehensive picture. And people are still trying to test that model at the very precise level, but we understand it pretty well. The thing that is missing is to unify gravity with everything else. And that's where string theory comes in, multiverses, all of these obscure, elaborate, intriguing mathematical concepts. And the world has been playing with this now for 30 years.
Yeah.
For a physicist of the type I am, even though I'm a theoretical physicist, my touchstone in the end is the real world. Doesn't describe anything that we observe. And the maddening thing is we've not seen any deviations really that might be predicted by these exotic models. People say, well, we need to go to higher energies, we need to look more precisely and so on, and all that's going on. But right now we're kind of in a dry hole, to use an oil business term. And we need to, either there needs to be some theoretical breakthrough that says, here's what you should look for, or we need to have some surprising experimental result. There are always kind of interesting experimental results that are 1 or 2 standard deviations out. Almost always they go away, but sometimes, that's what the fun of physics is.
So Okay, I'm gonna try and break some of this down into layman.
Yeah.
No, it does. I mean, I'm interested in this. I don't know if my audience is, but too bad. You have to listen. So because I want to do a couple of things. I want to break apart the differences between field theory, standard theory, string theory, M theory, and then the multiverse theory, and then maybe explain in layman's terms what exactly are they trying to accomplish. I mean, you said the one thing they leave out is gravity. So you get the weak nuclear forces, the strong nuclear force, and that, and maybe explain in layman's terms what exactly that means. And again, where quantum theory plays into that too, and what does that explain, and what are we lacking?
Oh boy, a model of these processes, these structures, consists of what's the collection of elementary particles that are in the model. So we have electrons, we've got quarks, we've got photons, neutrinos, and so on, the zoo of particles. And then some description of how these particles interact with each other. Okay, and so, for example, one kind of quark can change into another and emit a neutrino and an electron, for example, or a muon. And when you put these theories together, there's a certain mathematical symmetry that you put into it that relates how the different particles interact with each other in some fundamental way. And as I said, we got a pretty good theory that's got the quarks and the electrons and muons, neutrinos, all together in that nice coherent structure with a couple of parameters that one can go out and measure experimentally. Gravity, again, is the thing we don't know how to build in. And the notion of strings, the notion of more exotic objects like membranes, are an attempt to take the point particle models that describe these particles as points with no structure, and endow them with some additional structure that would give you properties that look like gravity.
And it kind of boils down to this, we call them particles, but are they really physical particles, or are we measuring an activity like a wave? I mean, because they're waves too, and this is the other kooky thing about this stuff.
Yeah, so that's the quantum mechanic bit of it. For the things that we call particles, they are waves, but most of the time they do show up as particles. So an electron, for example, is a very real physical thing. We can accelerate it in, well, old-fashioned TVs or electron tubes, X-ray machines. The electrons get accelerated. They're physical particles. There were experiments back in the early 20th century that showed remarkably that they also can behave like waves sometimes. And that's the quantum mechanical wave duality. The same is true of the particles of light, photons. That at one level, they are particles. Einstein got a Nobel Prize for the photo effect that showed they were particles. But of course, light is also waves, as we experience in our everyday lives by interference patterns and breaking it up into colors and so on. So there is this kind of wave particle duality that runs through everything as well. I think we understand that pretty well in the theories. Again, the hard part is the gravity bit.
And is there a gravitron, or is it just a field? I mean, we don't even know how to describe it.
We've not seen the quantum nature of gravity yet. Okay, we've detected the gravity waves. So that was, I helped with that when I was at Caltech.
Okay.
Get that project underway. It was a 45 year pull by one or several inspired faculty that started in the mid-70s and led to the detection of gravity waves directly about 4 or 5 years ago. And now gravity waves have become I won't say standard tool, but a not uncommon tool in astronomy. Okay.
And another one of the problems, with that scientists or theoretical physicists try to get their hands around with quantum mechanics is right this duality, but also this probability wave, right? The whole Schrodinger's cat thing. So
Right.
this dual existence, you can be in two states at once,
Yep.
and this is where multiverse comes from, right? I mean, so
Right.
and it was Stephen Carroll. Is that name?
Oh, yeah.
Right, yeah,
Sean Carroll.
Carroll. Yeah, Sean Carroll. Sorry.
He's at Caltech.
Yeah, so he's the one who's
Yeah.
super into this multiverse stuff, and I
Right.
listened to the whole damn thing, and he makes a pretty compelling case. I mean, he answers a lot of questions that I still don't believe it because it just seems too crazy for me. I can't imagine an infinite number of me's, just because my probability wave function collapses in different ways every single time, and literally constantly. But he makes I mean, he really goes into detail about like how the weight of the universe is still consistent even with the multiverses. And I'm like, I don't.
So, my reaction when I hear that kind of stuff is I often think about what Dick Feynman would have said. And that is, show me, okay? Make one prediction that your theory makes that I can go test experimentally.
Mm-hmm.
And then I'll start to take you more seriously. It is true that one of the ways of thinking about quantum mechanics, and Feynman actually was one of the pioneers in it, was the fact that the system explores all possible paths, all universes, and then at the end it kind of comes together and all these paths interfere and you get the answer. And that's fine, but show me, some non-trivial prediction that you've made, and then I'll start to take you more seriously. It's a very convenient way of thinking about quantum mechanics. One of the more impactful things I did was to understand how to explore those different universes on a computer for atomic nuclei. But again, the power of theoretical explanation is in making a non-trivial prediction.
Yeah. Yeah, that applies to the climate stuff as well.
Well, absolutely.
And if we did understand gravity better, what kind of breakthroughs do we anticipate? You're on Joe Rogan's show, and another guest on Joe Rogan's show talked about these gravity. Remember, I don't know if you're familiar with that particular episode.
No.
God, what was his name? In any case, talking about alien gravity projectors or whatever. I don't know.
Look, I read science fiction when I was a kid. I'm a great fan of 1950s sci-fi movies, but no. All right.
Not seeing it.
Where things are getting interesting and spooky is the ability to build quantum mechanical systems on a micro scale. So quantum computing is one instance of that. Quantum sensing, the ability to sense gravity, for example, with great precision, quantum clocks. So quantum technology, I think, is a growth area and may start to give us some insight into this Schrodinger cat kind of thing in a deeper level than we have currently. When I was at Caltech for 30 years as a professor. I used to teach quantum mechanics to advanced undergraduates and graduate students. And I used to tell them, think about it like a calculus, a set of rules, and don't think too hard about what it means because you'll get all confused and tangled up. And after you get tenure, then you can think about what it means. But for the moment, just accept it as a useful way of describing the world.
Yeah, that's pretty much where I'm at. I minored in physics, but the last class I took was quantum mechanics. After that, it just becomes a lot of math, and I was still a liberal arts major, so I wasn't used to it.
Yeah,
it was a lot, but I love thinking about the theories, no matter how confusing it is. It's interesting stuff.
Yeah.
Sorry, I told you I'd throw you a curveball on these things.
Okay. So. That's good. It is great fun, and one of the secrets that we scientists don't like to. Well, we do tell people, of course, is that most of us would do what we're doing, even if we weren't paid for it, because it's just so much fun.
It really is. It's amazing what we can do, and appreciate you coming on, helping inform the audience. It's a really interesting book, Unsettled, and certainly made a lot of waves. So,
Yeah.
And-
So it's right. As I told you when we first met a couple of months ago, it's such a pleasure to find somebody in Congress who can talk about these subjects in a factual and logical way. And kudos for
appreciate
that.
that. I appreciate it. We have to. There's a lot writing on it because there's a lot of very expensive propositions, very damaging propositions that occur if you get the problem itself wrong. So I mean, debating this is important because it wouldn't be so important again if it didn't affect our energy mix, our livelihoods in a very serious way. But it
And
does.
our environment. Yeah. So literacy is the first place to start and get people to just understand the basics about climate and energy. And then you can go on to this balancing on the basis of values and priorities.
Okay, well, maybe one more question. Have
Sure.
you seen a turnaround in public opinion, after this work? Because
Yeah.
really your kind of work, from you, Bjorn Lomborg, Michael Schellenberger, there's, I forget the authors' names, but
Alex,
lukewarming.
Epstein,
Oh,
Alex.
yeah,
Epstein, I
Alex
think,
is
yeah.
too. He
Right.
doesn't deal as much with climate change. He's more just kind of but literally, but these are all very good argumentations. They make a lot of sense. And I feel like most of it's new within the last 5 years or so. And so I would think that it's really the first time there's been a logical rebuttal to the alarmism. Before it was just like, there's nothing happening.
Yeah.
And then they're crazy. They wear tinfoil hats and nobody listens.
I think there is a sea change and it's accelerated in the last year or so. When you talk to people in industry and government privately, there's a very different discussion, as you probably know from your discussions in government. But also, the world has had a heavy dose of energy reality in the last 6 months. And they've started to realize that reliable and affordable is much more important than clean. And I think that is getting people to look harder to understand the problem better than they have. And then we might see some rationality come out.
I hope so. And we're trying to be a part of that conversation.
Yeah, that's great. That's great.
Steve, thanks so much for being on. It's
Okay,
really informative.
wonderful
Appreciate you.
conversation. Okay, very good. So long.
Got it.